The properties, we said that they are the key element to answer the question, is a transaction secured or not? We started with the ACID, atomicity, consistency, isolation, and durability. And then after we talked about the, let's say, the commitment and the transaction modes, the context of the commit and the rollback or something like that. And we define the bash scope transaction. I'll just make a small recap on that and we continue. One of the 4 transaction modes, actually, it was the bash scope transactions, where we defined the context of, actually, we have 4 modes, mainly the automatic or the auto commit transactions, plural. They're the one that they have only one statement to do, one query to do. And the explicit and implicit, they are the transactions that they have to start and be terminated within a statement, within a given. When we talk about the explicit, they have to be having a startup and a termination manually set by the developer. Yes, the program has to indicate clearly the begin of the transaction and clearly the commitment mode or the transaction mode at the end, either to commit or to roll back. This is the explicit mode. And for the implicit, the transaction, it has to start automatically after being actually after a list or a series of transactions being executed. Automatically, when the level arrives, the transaction will be launched automatically, implicitly. But the termination has to be explicitly set. Means the developer has to set either a commit or a rollback at the end of the transaction, to commit or to roll back the transaction itself. The 4th and the last one, which is actually a little bit actually more complex than the others, and it has to be understood no more no less. It is given the name bash scope transaction. It is a list of transactions that they have more than one command to be executed, and the command has a list of statements or instructions to do. Each command has to have a result. So by this, we talk about a multiple, let's say, commands to be executed, multiple active result sets. Here, acronym is the MAS transactions. They are bash scope transactions. Those are kind of transactions. They are not different from the regular T-SQL transactions, yet they have a specificity, which is they have more than one, let's say, command. We use the word command here, to be executed at the same time, and they have to have results also at the same time. Otherwise, either they get executed all or they fail all. There is one transaction, which is a bash scope transaction, with one transaction with many commands, and each command has more than one query or more than one statement to execute. So thus we talk about a multiple active result set transaction, let's say, type, and those are the defined bash scope transactions, the 4th mode, the 4th transaction mode. There are specificities, there are key, let's say, characteristics in plural of those bash scope transactions. Specifically and stressfully, we stress on this point, which is actually the transactions. Since they are actually one transaction, those many commands, they belong to the same transaction, they do not have the right to be interrupted as usual. The isolation has to be visualized here. But even manually, we cannot do, means the kind of the bash scope transactions, even the developer himself, if he tries to commit one command and, let's say, roll back one command, he will not be able to do, because they are belong to one transaction, either the transaction to be committed or the transaction to be rolled back. Whatever the number of the commands this transaction is having. Thus, the execution of one of the technologies that the SQL or T-SQL enhances the save points to indicate a frame point in between the life cycle of a transaction, whether to be executed or to be actually, let's say, to be utilized for as a referral point within the transaction body. It is not supported with the bash scoped transaction mode, transaction, let's say, type. What are the save points now? Let's have a deeper view a little bit of this context of save points. This is actually kind of a transaction regardless. This is actually non-mass, absolutely. Non-mass. What is the mass? Multiple active result sets. Those are the mass. The bash scope transactions, they are the mass. Remember here. Yes, so This is a kind of a non-mass, means it's not a batch scope transaction here. Why? We will discuss. We have explicitly mentioned, the developer explicitly mentioned in the beginning of the transaction, the name is tran, clearly given, and the termination of this transaction is here. Here it's clearly saying commit, the termination. So we have two slides here. This is the beginning of the transaction, and this is the termination of the transaction. The termination is a commit to admit. To admit all. But what is the all? Amongst of the content of the all here are all of this, and not only that, and also all of this. All of it is belong to the same transaction named tran. But here we can see in the second page, well, there is actually a commitment to roll back to a certain point. This is a save point that has been created already in the first page here. This is it. Save point 1. Save is a keyword. Tran is the transaction name. It's the same. And we are using a user-defined name here, save point 1, whatever. So we are creating a save point that later on in the same program we are referring to it. To rollback means all of those statements here in this block here up to here, this save point, is going to be rolled back. So we can cancel, means the rollback means we are not going to admit, we are not going to execute, we are not going to have the result of this list of queries here. How many statements we have, we don't care. In this case, we are having 1, insert, select, there are 3. This is a command because, and this is a command also, and also this is a third command. So the program will not look at them. We have only 3 statements, 1, 2, and 3 statements. Those 3 statements, they are going to be rolled back, means that results would not be committed within this program here. This is the effect of this save, the rollback to the save point. If we can cancel a part, or let's say a totality of content, or whatever, even a small part, even one query only, if we can control, means to roll back, or to commit only, means not only roll back, or even commit. So this is not a multiple active result set. Those results here, they are controllable. They cannot actually, they do not represent a force to either be executed all or fail all, to be committed all or to be rolled back all. No, we are able to roll back or to commit a portion of the program, and the rest no. So this is a non-Mars. This is a non-multiple active result set transaction, let's say, type or mode. Based on this explanation exactly, let's move to the next example here to distinguish what we saw here with this non-mass transaction with this mass transaction. To come back to this first part here, immediately I'm going to pass to the next, let's say, to the end of this transaction here. At the end, we are having user-defined name here, which is tran. Which is tran, and it is actually given a but what is this tran? This, I said, it's user-defined. Let me just come back to the prior slide. This tran, I said it's user-defined because I know the content actually, but here in this context, you not know. It is written in small. This tran here, let me come back to where it has been defined. Okay. We have actually the declaration of a transaction, SQL transaction, which is actually a transaction that has to have a name. In this context, it is given here the name tran, whatever. We are declaring a user-defined name tran to define a new transaction, yes. And this transaction is pointing 2 commands, the command 1 and the command 2. So command 1 has been linked to the transaction. It is in the body of the transaction, tran, and the command 2, the cmd2, is linked to the body of the same transaction, tran, the same. What is the content of the cmd1? And what is the content of the cmd2? Let's come back one slide before also. Transaction 1, command 1, it is simple, actually, a SQL command. It is a simple SQL command. It has one select, another select, another select, another select. So we have, in this example here, 4 queries. CMD2, it has, this is the CMD2, it's another SQL command also, CMD2, but it has only one query. It's an update, simple SQL query update. Simple one. Okay, it's acceptable also. But can we control the CMD1 from the CMD2 or the vice versa, CMD2 from CMD1? No, it's not the role even. It's not the text here. So these are standalone command, CMD2. And also the other one, the CMD1, is another standalone command, CMD1. So they are not related to each other and they are standalone. But at the end, we are executing a transaction that points those two. So since this transaction here, it points both. It points both transaction, the same tran, the CMD1, and the same transaction, it points the CMD2. So both of them, they are within the range of coverage of this tran transaction. It means that at the end, when we, let's say, execute the mode here, whether it is a commit or rollback, so both commands will be either committed or rollback. In this example, it's commit. So both commands, the CMD1 and the CMD2, context would be committed. There is no save point to use here to come back to a certain point here. So when we talk about the transaction, this is the context of a .NET query. It's a C# body. This is a program. This is the transaction keywords. So either to commit the transaction with its content, or to roll back the transaction with its content also, fully, regardless of the number of the commands. Here, we can see that this is a mass transaction. There is no save point. We cannot cancel one and execute one. It's not the role even here. So since we are defining a transaction that points two commands, the transaction once committed, the two commands are going to be committed. The transaction once rolled back, the two commands also would be rolled back also. So this is a mass transaction. So bus scope transaction here. It is a mass transaction. And the mass transaction is a transaction where we can see more than one command be executed, and each command has queries, standalone queries to execute, or statements. Simple. This is the context of the mass and non-mass transactions. Any questions, please, at this level?
No, Mr.
If you want to ask something, please speak, because the messages, I'm not going to keep reading the messages in another page. Okay, it's been a no, so we continue. The same thing, actually, here, the context before, actually, the context of the exception handling, I told you earlier that the lab that you have to solve, it is talking and discussing the exception handling. See this try here. You have a beginning of program that has, or that points a try. It has a startup, the curly brace here, the startup, and there is an and, which is here. This is the termination of the transaction here, the try, termination. And after that, there is a beginning of a catch-up block. The catch here, it's the place where if any issue happens, where in between here, this closing curly brace and this opening curly brace, let's say what it is, this opening curly brace, yes. All of what happens here, if any issue still up to here, up to the execution of the transaction. Yes, if any issue happens, during the run, this catch block will be executed, which is this block will be executed. Instead, the program will continue running, but this block will be executed, not the try block. Try and catch. Okay, good. The isolation level, see, we talk about the properties of a transaction, and here we talk about the isolation level. It is a context via which we see a betterment and the control of the transactions in runtime, and specifically in, let's say, a more an environment where the congestion is highly viewed or displayed, or let's say visualized. Congestion in the sense of the number of views and the amount of data being utilized at the same time is a little bit high. So we talk about the web as an example, the web www environment as per an example, the internet. Yeah, so this is the context of the isolation level here, where for what it would be actually applicable. It is to avoid issues that they happen within the let's say the environment with a congestion, with a high congestion, let's say something like that. The issues, we can just point them: the dirty red, the non-repeatable red, the phantom red, and whatever the isolation level we are going to tackle. There is a solution that matches one of the issues we talk here. We may use one of the isolation levels that solves all the issues. Yes, like for example, here we say actually serializable. Yes, there will be no dirty red. There will be no non-repeatable red. There will be no phantom execution or phantom red also. No, completely. So this isolation level here will solve all the issues. We can utilize the isolation level serializable upon this description here, upon this table here, to solve those issues, if they are the unique issues. If they are the unique, here actually it is a briefing to make you understand what is the isolation level only. So conclusion here: the isolation level is a context to solve the issues in runtime, mainly in runtime, and not only in runtime. It is in runtime within a very crowded environment, in the sense of with high congestion, means it is highly utilized at the same time. Well, very good example is the www environment. Everybody worldwide, they are using the environment at the same time. Not everybody, but a huge number of requests and responses, they are being seen upon the www environment at the same time, usually. Just I'm bringing your understanding only to see where to apply or to see the isolation levels in action. So no more, no less. But as a theory, the isolation level is a context of eliminating runtime issues that would happen on top of a transaction. And kind of, let's say, runtime issues. The dirty red here, we'll explain them all here. Those are examples of runtime issues. Let's explain those runtime issues here: the dirty red and the non-repeatable and the phantom red, whatever. So when we talk about the very crowded environment, or the environment with a high congestion during the runtime, usually there are issues that might happen. Let's talk about let's say two transactions would be executed at the same time, or two users, two candidates would be two different candidates, not transactions, user 1 and user 2. For example, any application, Bank Muscat or D-Wave even, or any application that uses a remote access, and there will be two users to use the same application at the same time, and they would pass transactions each. Yes, great. Let's say the user one, for example, the user one is creating an application, let's say session, for his account. He logged in, his username and password. Another user, he logged in also using his username and user password, the same application. So the application is handling both requests from both sessions, from both users at the same time. once, for example, uh, an insert, let's say, on actually an update happens from the user number one at the same at the runtime. Let's say, for example, the user number one is going to update his profile from an instructor to, let's say, student. Let's say something like that, from an instructor to a student. The user two is searching for students. Once the result of the query returns the value of the updated, the session actually is going to modify something. The updated value that the user one has done in runtime, this is dirty red. Why? Because it has not to happen. There has to be a validation of the request or the let's say whatever the task is being done by the user number one. There have to be a sort of validation. Thus, we talk about the dirty red since it is happening in runtime without validation or something, just in runtime in a volatile environment. Any action happens that actually occurs due to from the user number one, for example, any other user that sees the result of those behaviors, this is a kind of a dirty red. A dirty red since the user two, or let's say any other, the second partner, is capable to see the differences applied by the user number one, this is a kind of dirty red. Simple. It's like that. Usually we talk about the behavior in runtime. So this modification here to happen, it has to happen in runtime, not when the application is in off time. You know what does mean off time and runtime or online. A second issue we can discuss also the non-repeatable read. Here we can see a transaction being, let's say, a request being submitted by a user, and multiple values are going to be retrieved again and again and again at the same time, due to a reason or another. If actually, whatever, if there are actually updates or let's say any modifications brought by another, here actually the word session one, session two, session one, session two, you have to understand that he's an action done by user number one, and this is an action done by user number two. This is an action done by user number one. This is an action done by user two, and so on. So, session one, session, you have to be clever, understand that. The non-repeatable read actually is a scenario where which we can see multiple results being displayed from one entity. Let's say we display the details of a student, and you can see a student with two results. ID number one, the same ID, for example, but two contacts or two emails or two whatever. The profile is being duplicated two times. Due to what? Because there is another user has made an update in runtime, and the original data is still available in the result that the session one or the user number one has requested. Means the user number one has opened the application and searched for students. The list has appeared. At that time exactly, specifically, another user has, or a student has, let's say, updated his profile. The profile number one is already being retrieved. The new value, the new updated value, would be also displayed to the user number one, and this is because of the request is being done in runtime. So there is a kind of a non-repeatable read that has not to be set, has not be to be seen, either the profile one or the profile two. The application has to, or the request has to have a response which is either the old profile or the new profile. Let's say the old values or the new values only, not both, not a repeatable value. So once happens means new and old values being displayed. This is a kind of a non-repeatable read issue. It's an issue. It's a runtime issue. The third issue here, also the phantom read, it's a context via which still we can see actually some similarities, but even though we can see users, they are using the same application at the same time. User one is requesting a result, For example, searching for sport or searching for whatever, let's say events, today events in EduWave, for example. The list of the events being displayed, they are the available ones in the database. Any event is available in the database would be retrieved. But during the search, the retrieval would be actually having a new value if another user makes a new event or inserts a new event. So if happens, this is a phantom red. This is something that has been added in runtime only. This is a kind of a phantom red also. This is another issue. So it's another issue also. The phantom red is a scenario which we can see data being inserted, and also it considers that it matches a result of another request, of a request from another user. User number one is searching for something. User number two at the same time is inserting values that they match the request of the user one. So the results here would be displayed. The new one actually will be displayed. The new values will be displayed in the request response of the user number one. It would be included in the same results view. This is a phantom red. It has not to happen also. It's not the best practice that systems has to do, the phantom red. So the isolation level is the solution for those are examples of issues. The isolation level, one of the isolation levels, can solve those kind of, let's say, runtime issues. The isolation levels, they are different examples, but we are going to discuss some of them, no more, no less, to make you understand what does mean isolation level. Later on, we'll see the implementation. Those are examples with the example of execution here. Immediately, I'm going to discuss the serializable one because of those. Actually, they would not give you any kind of understanding in a clear view. But let's discuss the serializable. Based on that, we will distinguish the others. The serializable as an isolation level is a scenario via which you can see more than one entity being utilized in one transaction, and all of them, they are set into a deadlock state. I repeat, listen to me carefully, please. A serializable isolation level is a scenario via which we can see more than one entity being utilized from within the database, the same database, and all of them, they are being set into a deadlock until the serializable transaction being accomplished. Deadlock means they are blocked. None can utilize them. Nobody can utilize those deadlock entities unless the transaction in question is terminated, is finished. The deadlock is actually it's an occupation of a resource in order not to be utilized by others. Deadlock. It's a very powerful solution to all kinds of issues in runtime. No other users of the same transaction in runtime. Thus here, based on this understanding only, we can understand that the isolation level is a scenario via which we can see the transaction running without issues. Yes, that's the point. To isolate a transaction is to eliminate issues. It's not to make it deprived from the external environment. No, it is to execute it without issues. There are ways how to isolate a given transaction. Thus, we have to specify which isolation level we need in order to finish the task in question. We cannot say that this serializable is the best for all. No, remember that the entities inside the database, they might not be only utilized by one transaction at the same time. Depends on the context. But if it is the case that we need all the entities utilized not to be modified by any other user or any other transaction, so the serializable is the best option. No more, no less. Snapshot, you know what is a snapshot actually. It's not the first time we meet it. Okay. Let's have a small look actually to a transaction which is being set as a serializable transaction here. This is a real case, let's say, transaction. We are at the beginning creating a table, an entity. This is an entity, and we are inserting values to the created table. خلاص, now we have actually an entity inside the database, and the entity is the table itself. The table DBO test, the test database owner test, and it has values we have inserted into this table. Now let's create a transaction and utilize this entity for certain purposes without giving any chance to any other transaction to use this same table or any other user to use the same table without consent. Means they have to ask for permission. Any other transactions or interception has to ask for permission, and then after it will be actually either allowed or not. Thus, this is the transaction that has to start here like that manually, and this is the commitment mode. So here we are starting explicitly and terminating the transaction explicitly. This is an explicit transaction mode. An explicit transaction mode. The content of the transaction here, we have 1, 2, 3, and 4 queries. We have 4 queries to execute at the same time. Whatever the queries they are. Just to explain only this wait for. Wait for is actually it's a SQL Server command that gives us the chance to make the program be paused for a certain amount of time. In this example, 10 seconds only. Seconds, minutes, and hours. So for this example, it's in seconds only, 10 seconds only. The system will be paused for 10 seconds only. Any questions, please? Any questions at this level, please?
No, Mr.
Okay, we continue. This is the last thing actually we will discuss. It's not much. Remember that the context of the isolation level here, whether it is serializable or not, it is not a solution to implement for a database that you create in your local computer and that's it. No, it has to be implemented within a professional environment where we can see a highly, let's say, use rate of the entities in question. High use rate means entities they have to be actually used frequently and very with a very high number of requests, such as the web environment. Thus, we can see those issues: the phantom, the non-repeatable read, the dirty read. Those are examples of runtime issues in plural. Isolation levels, they are the ones to solve such an issue. Any questions, please? The last topic. Okay. The last topic in this chapter, which is talking about the distributed, let's say, systems, databases, or projects, or whatever. The distributed context of the distribution here is a scenario in which we can see more than one SQL server, for example, is being utilized for accomplishing one task. Yes, more than one database to use to accomplish a task, whatever. And those databases, they are available in different machines, in different locations. If they are running all together to accomplish one task and they are physically separated, thus we talk about distributed transaction. Simple. Actually, technically speaking here, if we want to create a distributed transaction, simply you add the word distributed, no more, no less, to indicate that there is an external command from an external environment and to accept it. Distributed transaction. This way, actually, we terminate this chapter number 5. Sorry, number 4, and we will start the chapter number 5 now. Unless you have any questions, I'll stop here. Let me open the chapter number 5. And if you have any questions, meanwhile, you can ask, please. I'll stop at this level here by just indicating what are the context of security that this chapter is going to discuss. They are the security related to types of transactions. They are segregated into themes, or let's say levels, something like that. And those themes here, they are the first and the building block to secure a database-based project. So here in this chapter number 5, we are going to discuss the SQL Server, let's say core activities, let's say creation, which is the whatever the list of functions or whatever they are. It's security here. The security of this core activity of this SQL Server is going to be discussed in this chapter number 5. No more, no less. So this way, if you have any questions, I'm gonna give you the chance to ask any questions, please.